All right, if you're deep in a calculus class right now, you know that integration can feel, well, pretty intimidating, right? It's like staring up at this giant mountain. But here's the thing, you don't need a ton of gear to climb it. All you really need are a few key tools and a couple of smart strategies. And that's exactly what we're going to do today. We're going to build your personal integration toolkit so you can turn those scary looking problems into something you can absolutely handle.
So, what's on the docket? First, we're going to nail down the 3 rules you just can't live without. These are the foundation. Then we'll jump into 2 super useful strategies: divide first and expand first. Think of these as your secret weapons. And finally, we'll wrap it all up and show you your complete toolkit.
Okay, let's get right to it. We're starting with the essentials. These next 3 rules, they're the non-negotiables. You're going to see them everywhere. They're basically the hammer, screwdriver, and wrench of your calculus toolkit. First up, the power rule. Honestly, this is your MVP. It's your number one go-to tool for pretty much any variable raised to a power. You know, like x squared or x to the 5th. The rule itself is super simple. You just add 1 to the exponent, and then you divide by that new exponent. That's it. The integral of x to the n becomes x to the n plus 1 all over n plus 1. This thing is an absolute workhorse when you're dealing with polynomials.
So you might be thinking, wait, what happens if n is -1? Because if you try to use the power rule, you'd add 1 to -1, get 0, and oops, you're dividing by 0. And we can't do that. Well, that's where our special case comes in, the log rule. The integral of 1 over x, or x to the -1, is the natural log of the absolute value of x. And it makes perfect sense, right? Remember how the derivative of the natural log of x is 1 over x? Well, integration is just going backwards. This is that one little exception that makes the whole system work.
And finally, to round out our top 3, we have the exponential rule. And you're going to love this one because it's so, well, easy. The integral of e to the x is, drumroll please, just e to the x. That's it. It's its own derivative, so it's its own integral. Seriously, it doesn't get much better than that. It's this cool, unique property that actually makes e to the x one of the most important functions in all of calculus. All right, so we've got our rules. Now for the fun part, putting them into action. Let's talk strategy. And our first one is a real game changer. Here's the secret. Sometimes the smartest thing to do in a calculus problem is a little bit of algebra first. Let's see what I mean when we're dealing with fractions. Okay, so you get a problem like this on a test. It's a big, messy fraction inside an integral. And let's be honest, your first reaction might be a little bit of panic, right? You start thinking, okay, where's the fraction rule for integrals? But hold on. The secret here isn't some new complicated rule. It's actually just about simplifying what's already there. And this right here, this is probably the single biggest trap students fall into. You spend all that time memorizing the product rule and the quotient rule for derivatives, so your brain just naturally assumes there's got to be a quotient rule for integrals too. But there isn't. It does not exist. Trying to make one up is like walking straight into a trap. It's the fastest way to get the problem wrong, for sure. So what do we do instead? It's simple. We divide first. Just take that one big fraction and break it apart, term by term. You divide x cubed by x squared, then 2x squared by x squared, and so on. And look what happens. After you simplify, that intimidating problem turns into a nice, clean list of terms you can easily integrate. We just use our power rule on each piece. And oh, super important, don't forget to add that plus c at the end. Remember, since the derivative of any constant is 0, we always have to account for that constant of integration. See? A little algebra completely transformed the problem.
Okay, on to our next big strategy. And you'll see it's built on the exact same idea. Just like we use division to simplify fractions, we can use expansion to simplify other kinds of expressions.
So here's another classic. You see a set of parentheses with some stuff inside, all raised to a power. And again, your brain might start searching for some kind of reverse chain rule or something complicated. But nope, there's a much, much simpler way to do this. And it's probably one of the first things you ever learned in algebra. The strategy? Expand first. Just multiply it out. Remember FOIL? First, outer, inner, last? You just do that, and boom. That 2x plus 3 squared becomes a simple polynomial, 4x squared plus 12x plus 9. And that, well, that's easy. We just hit each one of those terms with the power rule we already know. Slap a plus c on the end, and you're done. Again, it's the algebra that does the heavy lifting and makes the calculus a piece of cake. All right, let's step back for a second and look at what we've put together. It's a powerful and actually pretty small toolkit. And with what we've covered, you can now handle a massive range of integral problems. So here it is, the whole shebang. 3 basic rules: the power rule, the log rule for that special case, and the easy-peasy exponential rule. And then 2 key strategies: divide first for fractions and expand first for polynomials. That's your system. Get these rules down, but always ask yourself first, can I make this simpler with some algebra? If you can make that your first instinct, you'll start seeing that problems that looked totally impossible before are actually ones you can solve no problem.
Look, this toolkit we built today, this is your foundation. As you move on to trickier stuff like definite integrals or integration by parts, these rules, and especially these strategies, are always where you start. So the real question isn't just, can I solve the next problem on my homework? The real question is, what bigger, more complex ideas are you going to be able to tackle now that you've got the right tools for the job?